These are 3 parts inside your engine that fail quietly, cost thousands to ignore, and almost never get checked during a regular service. All 3 belong to the same system called PCV, positive crankcase ventilation. On direct injection and turbocharged engines, they cause the single biggest source of premature engine damage that most shops will not diagnose, and most owners never hear about until the repair bill has climbed past arguing. If your driveway holds a BMW N54 or N55, a VW or Audi 2.0T, a Ford EcoBoost, or a GM Ecotec, this one is for you. Gasoline engines once relied on a simple process called fuel wash. In port-injected designs, every intake valve was bathed in a steady spray of gasoline, cooling the metal and dissolving oil vapors before they could turn into stubborn carbon deposits. But that chemistry changed with the rise of direct injection. Instead of spraying fuel onto the valve, modern injectors fire straight into the combustion chamber. The intake valve now sees only air, no cooling, no cleaning, and no buffer against the oil-laden vapors carried in by the PCV system, which is positive crankcase ventilation. This small shift in fuel delivery creates a perfect storm. Without the protective wash, intake valve temperatures climb into a critical band between 195 and 290 degrees Celsius, where oil vapors and fuel residues stick, harden, and build up layer after layer. Toyota engineers first flagged this temperature window as the danger zone for carbon formation. SAE research has since confirmed that most direct injection engines operate right inside this range, especially under load or boost. The numbers tell the story. In 2008, only about 12% of new US cars used direct injection. By 2016, that share had jumped to nearly 1 in 3, and today direct injection engines power almost half of all new gasoline vehicles. This rapid shift means millions of cars are now running with hotter, unwashed valves, making them vulnerable to the quiet buildup that starts the chain of problems related to the PCV system. The chemistry is clear. Take away the fuel wash, add high heat, and the job of the PCV system becomes much riskier. That's why understanding this upstream change is the key to spotting trouble before it turns expensive. Tucked inside most modern valve covers, the PCV valve is a small part with outsized consequences. Unlike the old metal check valves that could be swapped in minutes, today's PCV is often a thin diaphragm molded directly into the plastic cover. When it fails, it does so in 2 distinct ways, each with its own risks. A torn diaphragm turns the PCV into a vacuum leak. Unmetered air slips past, the engine runs lean, and codes like P0171 or P0174 appear. Idle grows rough, a faint whistle might emerge, and the check engine light flickers on and off. Left unchecked, this extra air accelerates carbon buildup on intake valves, especially in direct injection engines. The opposite failure, a stuck or blocked check valve, traps crankcase pressure. Oil finds new paths, seeping past gaskets and leaking onto the valve cover, the turbo, or the rear main seal. In some cases, pressure spikes enough to blow out a gasket, dumping oil into the engine bay or onto the exhaust. Turbocharged engines may push oil into the intake, contaminating the intercooler and causing blue smoke on startup. The integrated design means a failed diaphragm on engines like the BMW N54 and N55 or VW and GM Turbo. 4-cylinder engines requires replacing the entire valve cover, turning a $20 fix into a $500 to $800 repair. Oil separators are supposed to be the last defense against blow-by before it reaches the intake. In theory, these components use baffles, mesh, or cyclonic chambers to pull oil droplets out of the vapor stream, letting only cleaner air pass onward. But on engines like the VW and Audi E88, Ford EcoBoost, and GM Ecotec, the separator is often just a thin plastic or silicone diaphragm tucked inside the intake manifold or valve cover. Over time, sludge and carbon coat the separator's surfaces. As the pores clog, crankcase gases can't vent properly. Pressure builds, forcing oil to find new escape routes, past gaskets, into the turbo inlet, or straight into the intake runners. Technicians performing flow tests on a used separator sometimes find barely a trickle where there should be steady airflow. In turbocharged engines, this failure is especially risky. Under boost, the system is designed to reroute crankcase vapors through a separate path, bypassing the intake manifold and dumping them upstream of the turbo. If the separator clogs or tears, oil-rich vapor gets pushed directly into the turbo's compressor housing. The result is sticky residue on the intercooler, oil pooling in charge pipes, and a thin film coating the intake valves. These failures rarely trigger a specific warning light. Instead, owners might notice blue smoke on startup, a faint oil smell at idle, or a gradual drop in boost pressure. Without a clear diagnostic code, shops may overlook the separator entirely, treating the symptoms without fixing the cause. The oil separator's quiet failure sets the stage for the next phase: carbon deposits that choke off airflow and drive up repair costs. Carbon buildup on intake valves doesn't just sit quietly in the background, it shows up where owners feel it most. Cold start misfires, sluggish throttle, and repair bills that seem to double overnight. Once oil vapor makes it past a failed positive crankcase ventilation valve or separator, it bakes onto the back of each intake valve, forming hard, uneven layers that choke off airflow. The result is a rough, idle, intermittent misfire code such as P0301 through P0304 and a loss of low-end torque that can be hard to pin on any single part. For many direct injection engines, BMW N54, VW and Audi EA888, Ford EcoBoost, and GM Ecotec, the only way to clear these deposits is walnut blasting. Shops use crushed walnut shells fired under pressure to strip away the carbon without damaging the valve or seat. But this service is only a reset, not a cure. Without fixing the upstream PCV or separator fault, the carbon comes back, sometimes in as little as 10,000 to 15,000 miles. Owners may pay $250 to $800 for a single cleaning, only to see the same symptoms return within a year. No manufacturer publishes an official cleaning interval, so shops treat blasting as an upsell, not a routine fix. For drivers, that means invoices pile up while the real cause, an overlooked integrated PCV leak, keeps funneling oil into the intake, guaranteeing repeat business for the shop and frustration for the owner. BMW N54 and N55 engines reveal their weak points between 70,000 and 100,000 miles as PCV diaphragms and oil separators fail. Repairs range from $500 to $800 for a new valve cover, with walnut blasting adding $200 to $250. The N54's extended warranty reaches 120,000 miles. The N55 does not. Volkswagen and Audi EA1113 and EA888 engines face PCV failures by 75,000 miles and separator clogs up to 120,000 miles, with repairs from $320 to $560. The Reese versus Volkswagen lawsuit remains unresolved, alleging owners were not warned about repeated failures. Ford EcoBoost 2.0-liter and early 3.5-liter engines develop PCV cracks after 90,000 miles, and a 2024 settlement now covers many 2.0-liter engines up to 150,000 miles. GM's 1.4-liter Turbo Ecotec sees failures as early as 70,000 miles, with a 2023 recall extending coverage to 100,000 miles. Most failures cluster between 60,000 and 120,000 miles, often without warning. Shops face a structural blind spot when it comes to failures related to the PCV system. Most manufacturers label the PCV valve and oil separator as lifetime parts, so routine service schedules never call for inspection or replacement. Without a factory maintenance interval, technicians are not prompted to check these components unless a clear trouble code appears or a major oil leak is visible. Modern engine control units, or ECU, quietly compensate for small vacuum leaks and crankcase pressure changes by adjusting fuel trim. That adaptive behavior can mask early-stage PCV failures, keeping the check engine light off until the system is overwhelmed. Meanwhile, the integrated design of today's PCV systems buries a torn diaphragm or a clogged separator inside the valve cover or the intake manifold, so those parts are nowhere near as accessible as the old screw-in valves. Shops often skip borescope inspections or smoke tests unless the owner specifically requests them, since the labor to reach these parts can be substantial and the symptoms overlap with more common problems like spark plug fouling or MAF sensor errors. As a result, early warning signs slip through undetected, and by the time the problem surfaces, the repair has grown much more expensive. For many owners, the first sign is a costly invoice, not a simple fix. Spotting a PCV problem before it gets expensive starts with the right questions and a sharp eye on the details. Trouble codes, P0171 and P0174, which means System 2 lean, are early warning signs, especially on BMW N54 and N55 models, Volkswagen and Audi 2.0T applications, Ford EcoBoost vehicles, and General Motors Ecotec engines. Ask your shop, is the PCV valve integrated into the valve cover? And will they perform a smoke test or a bore scope inspection? Request photos of the intake valves before and after cleaning and get a written estimate that separates labor from parts. Compare the cost. A proactive walnut blasting or PCV service at 60,000 miles can run $400 to $600. Wait too long and you are looking at $5,000 or more for a head rebuild, turbo replacement, or valve cover overhaul. If the shop recommends a catch can, press for details. Is it baffled or heated? Does it fit the factory routing? Under the Magnuson-Moss Warranty Act, your warranty cannot be voided just for installing a catch can unless the part itself causes the failure. The evidence on catch cans is still mostly visual, but respected voices like Jason Fensky say they help. The key is documentation. Keep receipts, monitor for codes, and demand clear answers. Early action means control before a silent PCV leak turns into a 5-figure repair. Today, a failed PCV valve or oil separator on an N54 2.0T or EcoBoost can quietly turn a $200 fix into a $3,000 repair, and most shops still skip the checks. Until inspection intervals reflect real risk, the most expensive engine damage remains the one you never see coming.